Hello, Miss Winelander here, and we're going to go through the Multiplying Special Cases Quiz Retake. So this is for Algebra 1B, Unit 3, Lesson 4. So first, let's just summarize how you're going to earn points back on your quiz. So first, you're going to finish watching this video of me going through how to solve each question on the original quiz, and pay close attention for the secret word. So you'll need to type in the secret word into the Google form in order to be sent the retake. So then you'll complete the Google form, complete with the secret word in there. After that, a memo will be sent with the quiz retake attached. You just have to answer the questions that you missed the first time. So this is showing that you have mastered all the concepts. If you got a question right the first time you took the quiz, we assume you understand that concept. You do not have to retake that. So after you answer all those questions, make sure that you show your work. So you can print off the retake. You can do it on a separate sheet of paper, whatever works best for you, and then send that webmail back to us, letting us see that now you understand the concepts, and we'll adjust your quiz. Alright, so let's get started. The first question here says, find the degree of the monomial. So for the degree, what we're looking for is we're looking for the exponents and the variables, and we're going to add them together. So 6p cubed, q squared, we have exponent of 3 and 2. So 3 plus 2 is equal to 5. So the degree is 5. For number 2, we're simplifying. So 7t squared plus 9 plus 6t squared plus 8. So there is parentheses there to let you know that you're taking this grouping plus this other grouping. Because you are adding, the adding would get distributed. So you'd be left with 7t squared plus 9 plus 6t squared plus 8. So it almost look exactly like as if you didn't have the grouping symbols, but it's not always going to be the case, especially if there's any subtraction symbols, so be careful. Now you're going to try to combine like terms. Let's recognize that 7t squared and 6t squared are alike. They both have the term t squared. Another term would be 9. Other constants like 9 is 8. So let's add like terms. So 7t squared plus 6t squared. 7 plus 6 is 13. So we have 13t squared. Now we have 9 plus 8. 9 plus 8 is 17. So we have 13t squared plus 17. All right, for number 3, we're simplifying. And again, I see parentheses, but this time they're saying that you take 3n multiplied by that whole section there in the grouping symbol of 4n squared plus 5n. So that means we're going to use the distributive property. We're going to take everything on the outside, distribute it to everything on the inside. So 3n times 4n squared. Then you're going to take 3n times 5n. Alright, so 3n times 4n squared. 3 times 4 is 12. N times n squared is n to the third. You would have 3 n's total. Or you can think about using your exponent rules that when you multiply exponents with the same base, in this case n, you add the exponents. So 1 plus 2 is 3. Then you're going to add 3n times 5n. So 3 times 5 is 15. N times n is n squared. Now we can't combine these further because they're not like terms. N cubed and n squared are not alike. So that is our final answer. For number 4, we're factoring. So remember, when you factor, you're looking for terms that when you multiply, you get to the same number. So like factors of 10 would be 1 and 10, 2 and 5. In this case, you start having variables here. So you think, well, what do both 18s and negative 63 have in common? So you can factor out that common factor. So let's just write some factor lists so we can determine that. So 18s. So what are ways you can get to 18s? You could have 1s times 18, or you could have 1 times 18s. Let's see, you could have 2s times 9, or 2 times 9s. You could have 3s times 6, or 3 times 6s. And I can't think of any others that we can have. So let's look at negative 63. So we could have negative 1 times 63, or 1 times negative 63. We can have 2, and whenever there's sometimes a larger number, sometimes I bring in my calculator so I can try to see which other one. So let's do 63 divided by 3. Oh, I guess that's 21. So we know that's a factor. Is 3 and 21. So we could have negative 3 and positive 21, or we could have positive 3 and negative 21. What are some others? So 63 divided by 4. No. 63 divided by 5. No. 63 divided by 6. And sometimes you go through those until you get to a factor, if you can't recognize them off the top of your head. So here we got 7 and 9. So we could have negative 7 times positive 9, or positive 7 times negative 9. And now you're looking for the greatest common factor. So what's the largest number that they each have in common? And I see 9. So that's what we're going to factor out. So we're going to say 9 multiplied by 2s, that's the factor pair for 18s, minus 7, because that's the factor pair for negative 63. And just to kind of confirm, so 9 times 2s is 18s, 9 times negative 7 is negative 63. So this is our final answer of factoring. We have two terms that when multiplied together get to our original. All right, for number 5, we're looking for what is a simpler form. So again, we're going to use the distributive property. So we have 5x to the third times 5x to the third. And then we have 5x to the third times negative 2. Now we have 2 times 5x to the third. And the last bit of pairs, 2 and negative 2. So plus 2 times negative 2. Let's start simplifying. 5x to the third times 5x to the third. 5 times 5 is 25. X to the third times x to the third is x to the 6. Now 5x cubed times negative 2. 5 times negative 2 is negative 10. So we have negative 10x cubed. 2 times 5x cubed. 2 times 5 is 10x cubed. And 2 times negative 2 is negative 4. So combining like terms, so I see the like terms of x cubed and x cubed. So negative 10x cubed plus 10x cubed. That's 0. So our final answer would be 25x to the 6th minus 4. For number 6, you're doing a very similar thing. So x times x, x times 5, 7 times x. You're taking, remember, everything to the outside, multiplied everything on the inside. And 7 times 5. So simplify. You get x squared plus, that's a squared, plus 5x plus 7x plus 45. Now, combining like terms, 5x plus 7x is 12x, and you still have x squared plus 12x plus 45. And as you're taking the retake, remember that you are paying attention for the secret word. So today the secret word is success. So again, that secret word is success. Make sure that you are paying attention to that so you can type that in. Again, success. For number 7, we're looking for simplifying. So we have 2z minus 3 squared. So there are 2 ways that you can think about this. Squared, you know, means multiplied by itself. So it's 2z minus 3 times 2z minus 3. So you can do what we did before, the distributive property, distribute everything to the left, everything to the right. Or you can use that formula. So you can take the first term, in this case 2z, and square that, plus 2 times the first term, which is 2z, times the second term, which is negative 3, and then add the second term squared. Both of those will get you the same response. So if we continue with what we just wrote down, 2z squared, 2 squared is 4, 2 times 2, z squared is z squared. 2 times 2z is 4z times negative 3 is negative 12z. Negative 3 squared, negative 3 times negative 3, which is positive 9. So that would be our final answer for this question. And you would get the same thing if you did the distributive property as well. For the last question, there was a little bit of work that involves in this. It says, write an expression for the area of the shaded region in its simplest form. Show all your steps. So the shaded region, sometimes I write this with words first to kind of help me walk through, like, what am I trying to do? All right, so the shaded region looks like you're going to take the rectangle, that whole rectangle, and you're going to subtract that square. So now let's think about, well, how do we do that? So the rectangle, the area of the rectangle is length times width. So in this case, it's x plus 10 times 2x plus 5 minus x plus 1 squared. So let's simplify. The first one, we'll do the distributive property. So we have x times 2x first, then x times 5, then 10 times 2x, times 10 times 5. All right, then we're going to subtract the other term here. So since we're running a little bit low on space, let's kind of use our space over here to write that out. So just like before on the last question, there's 2 ways to solve that. So we can take the first term, in this case x squared, plus 2 times the first term times the second term, plus the second term squared. So if we simplify this, we would get x squared. 2 times x is 2x, times 1 is still 2x. 1 squared is 1. So we're going to subtract all of that, remember. So let's start simplifying. So x times 2x is 2x squared. 5 times x is 5x. 10 times 2x is 20x. And 10 times 5 is 50. Now remember that here we're subtracting, but we got to distribute that subtraction. So we got minus x squared minus 2x minus 1. When we combine like terms, we get 2x squared minus x squared. So we just have x squared. 5x plus 20x, 25x minus 2x is 23x. 50 minus 1 is 49. So that would be the expression for the shaded region in simplest forms because we cannot combine any more like terms. So just as a reminder, your next step is to answer all the questions below this video, and then you'll be assigned a retake as long as you paid attention to that secret word earlier on. And